Okay, so we are going to continue with three-dimensional coordinates. We're going to talk about the midpoint formula. Can someone please explain? How about you do this first? Turn to your neighbor and explain to each other, discuss how you find a midpoint. Part 3. Midpoint. Uh-huh.
Just take the distance and halfway.
And how do you find that?
Or you take like you like divide by two.
Divide what by
Like
two?
you have like the 2 points.
This
You take the 2 points, you add them, and you divide by 2. That is what you just described. You just said add and then you just said minus. Which one is it? Kyler is confusing himself.
You add.
Okay. Averaging. Okay, so if we're now in 3 space, is it going to be any different?
Probably not.
It's not. We are still averaging the x coordinates, averaging the y coordinates, averaging the z coordinates for our midpoint. So, I'm going to give you 60 seconds to see what you can come up with for a midpoint on your own, and then we'll do it all together. Okay, turn to your neighbor, compare your answers. This is what I heard multiple times. -1, 0, 15 halves. Do you agree? There's my work. There's the answer that I heard. They match up. Cool. Let's talk about some equations in 3 space. If, I'll write this on the board. If we had x squared plus y squared equals 4, if we graph that in a 2-dimensional plane, what would we get? A circle with radius 2. Okay? If we throw a circle into 3 space, what does it look like? Well, I'm just saying, like, what would it look like? We have a circle in 2 dimensions. In 3 dimensions, it can become a sphere, right? Like a ball, okay, but a sphere. So the equation of a sphere is going to look very similar to that of a circle in 2D, but in 3 dimensions we're going to have a z. Okay, so now we have a z minus j, the quantity squared, so we can identify the center as hkj. And this is still radius squared. A lot of people want it to be radius cubed, but it is still radius squared, right? So if we wanted to write the equation of a sphere with a center at 2, -4, 3, and a radius of 3, then that would look like x minus 2 squared plus y minus -4 squared plus z minus 3 squared equals 3 squared, or in this case, 9. Now, fun things you might get to do with problems that involve the equation of a sphere. They could give you 2 endpoints of a diameter. What would you have to do? You would find the center by doing what, Kylan? Using the midpoint formula. How would you figure out the radius? Find the distance of the diameter and divide by 2, or you can find the distance from endpoint to center, and that would be the radius. Okay, they might give you the center and an endpoint of a diameter where you would have to use the distance formula to find the length of the radius. Okay, so in your homework tonight, you're not always going to get straightforward problems like this. You may need to use the midpoint and or the distance formula to help you come up with the center and radius so that you can write the equation of the sphere. Okay. Other problems you may see. Does this look familiar? Okay. This is a sphere equation. And I need to determine, we need to determine the center and radius. How will we do that? We're going to have to complete the square to put it in standard form. How many times will we have to complete the square, Lee? 3 times. So let's group things together. We have x squared minus 2x plus a mystery number. We have y squared plus 4y plus a mystery number. And we have z squared minus 6z plus a mystery number. And then I'm going to go ahead and move this 8 to the other side. And then we're going to have to add those 3 mystery numbers to balance out our equation. Matthew, what completes the square for x squared minus 2x? Amanda, what completes the square for y squared plus 4y? 4. Grant G, what completes the square for the z's?
9.
So we have x minus 1, the quantity squared, plus y plus 2, the quantity squared, plus z minus 3, the quantity squared, equals 6. Okay. Sarah, where's our center?
-1, 2. I'm kidding. It was 1, -2.
Good catch. Layton, what's our radius? Radical 6. That is r squared, so our radius is radical 6. Very good. Okay. Here's where I'd like you to just put your pencils down, sit back and relax. Okay. I want to show you some of the things that we can create when we put our conic sections in the free space. Okay? You will not have to graph these. You will not need to know the names of these. I just want to show you just so you can see what they look like. You are not going to have to do any of this. Do not panic. I just want to show you. Okay? First, this is an ellipsoid. Okay? So it looks very similar to the equation of ellipse, except we have the z minus j squared over c squared. Okay? So what does this look like in real life? Blue. Anything else? Just blue. A rugby ball? Pill. That's the first time I've heard that one. Okay. This is an elliptic paraboloid. So it's like a parabola where the outsides are all in elliptical shapes. You see that? What does that look like? Batman pretty cool. Okay. And then we have a hyperbolic paraboloid. Right? Doesn't it look like a Pringle? That's what I think every time. Or a saddle. Pringle. Now we're all gonna get hungry. This is a hyperboloid of one sheet, and then this is a hyperboloid of two sheets. So they're both hyperboloids, just like that one meets up in the middle, this one doesn't. So these are our three-dimensional conic sections. Aren't you glad I'm not going to make you graph those?
Yes.
Okay. So this is your homework. Your homework just focuses on midpoints and the equation of spheres. Okay. What I'd like to do right now, we are going to go over our final, but I'm going to go ahead and give you my Twitter handle so that you can vote for your favorite